After the restart, we received the shell, the Patek implant connection, and also we elevated our privileges using UAC bypass we have actually worked on. This time we will work on some of the Patek implant commands to demonstrate how we can utilize the TA505 tradecraft or their IOCs here. We will try to exfiltrate some data, discover some sensitive information in this system, as well as try to collect some useful information that we can use against the network itself, because currently we compromise only one single system, which is a Windows 10 and up to date. This is more like a financial service endpoint. So if a user works for a larger organization, a larger financial organization, they will have a laptop or endpoint pretty much like that, up to date, well protected, and everything is restricted. Sometimes there will be exceptions, and we will actually leverage those exceptions as offensive engineers. In this case, Patek implant has two different components here, two different sessions. The one session we received was high integrity process, and it was leveraging the UAC bypass. The second one was a normal one. It comes with the persistency command. So we don't elevate our privileges unless it is necessary. Normally, this is how it works for the TA505 as well. In some campaigns, for some systems, they did not even elevate their privileges on the endpoints, but they elevated all of those privileges or necessary information on the other systems, such as the servers or Active Directory privilege escalations. Now we will talk about Patek implant basics, and then we will talk about how we can use similar tradecraft just like TA505. First of all, we can generate some IOCs and collect information simply. We can do this in our high integrity process. And we are privileged here, which is great. We executed net users. We can also collect all local administrators of a system using this command as well, net local group administrators. They're actually interactive, and we can give commands like that. And the user won't see anything visually. We will still generate some IOCs. Windows Defender may not see anything. However, this doesn't mean that it doesn't watch us. Some of those behaviors will be always monitored. The second one is, of course, even though we try to bypass things, Sysmon or EDR or event tracing for Windows tools will monitor us, and they will identify our IOCs, and they will be still malicious. That's why we may lose our implant. So the best thing here is we can fork another implant. Using exec thread sharp assembly, we can create a new thread using our own Patek implant executable, which is a .NET assembly. This time we give parameters though. This one is WebSocket and WebSocket for this link. It is pretty much like HTTP, HTTPS, but it works just like that. And if we hit this implant will upload the Patek implant executable in memory, and the remote side, this instance, will load this using system reflection assembly load, and we'll run this with the given parameters. The parameters are WebSocket, which is the way back connection, the reverse connection type. And the second thing is, of course, the link of the implant. This is our WebSocket service. When we go back, we will see 3 implants now, which is great. But still, this is too noisy. In our example, we have shown this part, but maybe we should do something very clever. Let's use the same implant, and this time give a different parameter. Instead of giving WebSocket, maybe we can use SMB, and maybe we can give a certain name. And what we are trying to do here, the SMB is simply SMB name pipe. So this implant will still will be loaded using the system reflection assembly, will run as a different thread, though it won't connect to our service pack. It will listen to the SMB name pipe. Our implant will wait for another implant to connect and manage it. So we will create a star chain here. I'm creating an SMB name pipe here, for example, Office 2019 or MS Exchange, whatever is convincing for you. In this case, Office 2019 or just Office would be pretty good. I'm using Office 2019 now. So the executable is uploading through our secure channel, which is WebSocket. And after that, there will be a new implant running on this SMB name pipe. So quick question here is how we will connect this. That's linking. That is another feature of our tool, Patek implant. It is similar for Metasploit or Cobalt Strike. Metasploit also received this update if I remember correctly, but this is the core feature of Cobalt Strike. So TA505 also used SMB name pipes for implant-to-implant connections. So we will give Office 2019 as the SMB name pipe to connect. So what we are doing here is linking this IP address for Office 2019 tag. If it works, we will receive another implant. And this implant is new, and it arrived through this implant. So now we have two implants connected now. As we can see, this is a nested implant. We can repeat this action for TCP and UDP as well, and it is available in Patek repository training videos and some other commands that will assist you here as well. But we will move on with the implant we created, and we have things to do for TA505+. So we currently use this implant. This is SMB named pipe. If it dies, it will die, but it won't kill any thread connected to us. This is actually operational security because we can get one or two web sockets at the same time. If we get hundreds of those sockets or tens of those sockets, it doesn't make any sense. It will be too visible to our defense guys, blue teams, and they can identify us very fast. Instead, we can get one or two, maybe three web sockets with backups, but the rest of the communications must be based on SMB, TCP, or UDP, aligned with the internal traffic, so we will blend in.